Okay, for laboratory 1.2 for introduction to microprocessor, lab 1.2 activity 1, the coding, it requires us to write and assemble a program to add the following data and then use the simulator to examine the CY flag. So the data is 92H, 23H, 66H, 87H, and F5H. So we start with kill, because I have already written the coding for this activity, so I just have to open it. Activity 1.2. Alright, there is it. Open. So this is the coding for the activity 1, which is the data that requires us to add, which is the 92H, 23H, 66H, and so on. So I have assembled it. So there's no error and there's no warning, and I built to have a hex file. So this coding have a hex file, so we need to simulate in the simulator using sim8051. Okay, so we have open inside it. So 1.2 hex. Okay, so there you go. The information has been transferred in this code viewer. So there you can see 92, 23, 66, 87, and 05. So we click on this single step through program, and as you can see, there is no change in R0 until R7, ACC, PSW, and the stack pointer still 07. And keep on clicking single step until you can see there is a change on the 003 a at 23, and the AC would be 92, and the PSW is 01. So click again. There is a changes in this AC, which is B5, and PSW is 01. Stack pointer is 07, and so on. The changes in this AC 1B, and the PSW for this code at 87 hashtag 87 will be 40, because 1000000 change to hex, it value will be 40. Okay, and click again. It value is 80, I'm so sorry, and this one the value will be 40. Alright. So there is so that is the result for laboratory 1.2 for activity 1, which requires us to write and assemble a program to add a following data. And next proceed to the activity 2, which requires us to write and assemble a program to load 4 different values into each register from R register 0 to register 4, and then push each this register onto the stack. So this is the coding for activity 2 lab 1.2. Okay. Alright, this one. Okay, open. So this is the coding for activity 2, which is required us to load 4 different value into each register. I choose 0, 1, 2, 3, 4 into each register from R0 to R4, and then I push each of the register onto the stack. So the coding for this program will be push. It requires push 0, 1, 2, 3, and 4. So assemble all the codes, and there is no zero error and zero warning, and build this program. So a creating hex file. So let us simulate this program. Okay, so this one open. Okay, so as you can see, there is the transfer information from what we have written in the kill. It transfer to this code viewer. So as you can see, there is 0, 1, 0, 2, 0, 3, 0, 4, but it register 1 until 4. I register 0 until 4, and then it push into the stack. And so the stack and the speed register after this. Okay, so click on the single step, and there you can see the AC, PSW, and step pointer still 07, and click on and then as you can see, there is a different in R1, which you transfer the number in register 1. So there is 01 in register 1, and so 02 in register 2. When you click the single step program, and the AC still remains 00, and the PSW still remains 00, and still the stack pointer remains 07. And click to see more changes in this. So when that push, it turns out it came out the 04 in register 4. Then push 1, still remain, but the step pointer change to 08. Okay, and then 02 push, and then 03 push 03, and the step pointers keep changing, and 04 step pointer change to 0B, and end. So this is the code for this is the result for activity 2 for laboratory 1.2, which is examining the carry flag and the stack. So that's all for lab 1.2. Pensel set ada lain apa ni? Pensel pemadam. Memang. Nak pergi dah ke? Lepas tu. Oh, akak tunggu bawah. Akak ada apa? Okey lah. Allahu Akbar. Ya, okey. Zero. Okay.